So now we have a new section, section 14.8, and the meaning of the title will become very clear soon, the method of Lagrange multipliers. But this section is a continuation really of section 14.7. And since it is a continuation, let me just recall quickly the main problems or the main questions in 14.7. Okay, 14.7. In 14.7, we have the following problems. Find the extreme values of xy on. Again, extreme means maximum and minimum, maximum and minimum. Okay. Find the extreme values of f of xy on. The first one, the whole domain, the whole domain. And here, in the whole domain, we ask about local, max, min, and saddle point. So this is the first question. Find the local maximum and local minimum and saddle points. Okay. Second question, find the absolute. We need on a closed unbounded regions. But here we need absolute, max and min. And here we consider the regions like a triangular region, a rectangular region, circular region, mainly circular region, mainly these two, or in general, or any other regions, but mainly the first three. We concentrate on this, either rectangular, triangular, or rectangular, or circular region. So here we need the absolute maximum and minimum on these regions, on these regions, okay. Plus optimization problems. Okay. So here these problems usually will end up with one critical point, and then you will end up with absolute max or absolute min. So mainly you have two questions about absolute and one about local. Okay. Okay, so this is what we did in the previous sections. You have, let me say, three problems. Okay. Now in this section we have two more problems. So now, okay. We have two problems. What is the first problem? It is the following. Okay. Pay attention to the problem. Make your first objective to understand the question or the problem in this section. Make sure you understand the question, okay? Because at the end, you will have a procedure for a solution. You have to apply or you have to follow a procedure for the solution. So what is the problem, the main problem in this section? Okay, find the extreme values at maximum and minimum values of xy on the curve gxy equal to 0 in the domain of f. Okay. So graphically you have the following. Okay. This is x and this is y and this is z. We have a function f, so this is a surface. This is a surface. Z equals of x, y. You have the domain. The domain will be in the xy plane, but I will not take the whole domain. I will take part of the domain. And which part? It is really the points lying on a curve. So this part lying on a curve. So this is g of xy equal to 0, a curve. This curve, for example here ممكن يكون g ممكن يكون circle x square plus y square is equals 4, or ممكن يكون just a curve x square 1 equals a piece of a curve, part of a parabola. Okay. You have a curve in the domain. I need to find the maximum values and the maximum and minimum values of f on these points. Okay. يعني my domain will not be the whole domain of f, no, just part of the domain. Which part? The points on the curve. The point on the curve G. Okay. For this point. So at what point on the curve will f have a maximum? At what point on the curve G will f have a minimum? Okay. طبعا these curves, this curve here, يعني the image of this curve on the surface would be something like this, for example. Okay. So the image of these points on the curve will be this. I need the largest value of z, the smallest value of z, the largest value of f, the smallest value of f. Okay. So I need to find the maximum and minimum values of f on the points on G. At what point on G will f have a minimum? At what point on G will f have a maximum? Okay. This is the question. Okay. This is the main question of this section. Okay. If the question is clear, please write one in the chat. Write one in the chat. Again, the main thing is to understand the question, because at the end you will have a procedure for solution. Okay. Okay. So this is the definition, the meaning of the question. Okay. This question can be reformulated or stated in a different way. Okay. Equivalent statement. Okay. The same question we restate it as follows. Okay. Find the extreme values of x, y, subject to the constraint g x y equal to 0. Okay. Here we are using the word constraint. Okay. What is the meaning of the word constraint? Okay. What is the meaning of the word constraint? It means condition أو restriction, تقييد أو شرط. Okay. يعني find the extreme of x subject to the constraint, يعني عرضة للشرط أو للتقييد. Okay. Basically it means what? Okay, it means the following. يعني find the extreme values of f not over the whole domain of f. No, I need only on the part of the domain on G, on the curve G on the domain. Okay. And there is a restriction. The restriction, I need the extreme values of f not over the whole domain. No, just over the points on the curve G. This one, on the curve G. Just on this, on the points on the curve. So basically it means find the extreme values of f on the curve G equal to 0. This is what it means. Okay. They have the same meaning. Okay. Okay. Now this is this is the statement of the problem. Okay. Now how to solve it? There is a theorem that tells us how to find the solution. Theorem here. Okay. This theorem describes how to solve that problem. Okay. So assume gradient of f at gradient of g at xy not equal the 0 vector at all points xy on the curve gxy equal to 0. So assume the gradient of g is never 0 on the curve, on the curve. Okay. Then the extreme values of xy, i.e. the maximum and the minimum values, if they exist, occur at points x0, y0. Okay, so the solution will be the maximum and minimum occurs at a point x0, y0. what is the condition satisfied by this point x0, y0 on the curve. أولا on the curve gxy equal to. So it is natural, the point I need it has to be somewhere in the curve x0, y0. This is natural. It has to be because this is my domain. The domain is just the point on the curve. Okay, satisfying on the curve. That's satisfying the point. That's satisfying. يعني satisfy. يعني these points x0, y0 satisfy the following condition. Gradient of f at x0, y0 equals lambda gradient of g at x0, y0 for some real number lambda. Okay. Really, يعني x0, y0 the solution on the curve where the maximum or minimum occurs satisfies this gradient equation. Gradient of f at x0, y0 equal lambda gradient of g at x0, y0. Okay. For some real lambda, for some real number lambda. Okay. Lambda here has a special name. Okay. Lambda is equal. Okay. Notice here the gradient of f is a vector. Gradient of g is a vector. So you have a gradient of f equals lambda times the gradient of g. And the gradient of f is a multiple of the gradient of g. This vector is a multiple of this vector. A multiple. Since it is a multiple of two vectors, lambda is called a multiplier. Lambda is called a multiplier. Okay, because هنا it is acts as a multiple. A vector is a multiple of another. So lambda is a multiple. So it is called a multiplier. Okay. And specifically a Lagrange multiplier. Okay. Lagrange is a French mathematician. A name of a French mathematician. So it is called a Lagrange multiplier. Okay. And this explains now the title of the section. The method of Lagrange multipliers. Okay, the method of Lagrange multipliers. Okay, so this explains the title, because in this theorem really we have a method, or this theorem gives us the solution, or really a method for solutions. Okay, now from this theorem here, of course, how to find the maximum and minimum. From this theorem we get the following steps. Steps for solving the given problem. Finding the extreme values of f on the curve g equal to 0. Well, in fact, from this, we have to do the following. And really, this theorem gives us the following steps. 1, solve the system. Okay. Gradient of f at xy equals lambda gradient of g at xy. And g of xy equal to 0. Why? Because of them. This theorem says the solution, the extreme values of f, if they exist, occur at point x0, y0. What is the condition satisfied by the point x0, y0? They are on the curve, so they have to satisfy the equation of the curve. They satisfy this gradient condition, gradient equation. So I take the gradient equation. So the solution x0, y0 have to satisfy these two equations. Then just solve the system to find the point. Now here, what are the unknowns? You say solve the system. What are the unknowns? The unknowns, the point xy. So I need to know what is x and what is y, and also lambda. So I have 3 unknowns: xy for the point, and lambda, the real number lambda. I have 3 unknowns. To have 3 unknowns, or to find 3 unknowns, you have to have 3 equations. Do I have 3 equations or 2 equations? Okay.
2.
Are there 3 equations really, or 2 equations?
2 equations.
So here, initially, there seem to be 2 equations, but for 3 unknowns really to be able to solve, I have to have 3 equations. And in fact, we have 3 equations, not 2. Okay. Why? Because of what is the gradient of f? It is f sub x, f sub y. lambda. What is the gradient of g? G sub x and g sub y. So this becomes lambda g sub x, lambda g sub y. You equate the component, you get f sub x equals lambda g sub x and f sub y equal lambda g sub y. In fact, the gradient equation contains or gives two equations, f sub x, lambda g sub x, and f sub y, g sub y. You have two equations, in fact. So we write them in this manner here. This is f sub x at xy equals lambda g sub x at xy, and f sub y at xy equal lambda g sub y at xy, and then g of xy equal to 0. So in fact, I have three equations and three unknowns. The unknowns are lambda and xy. And for us, we need the point xy. We need the point, okay, xy, because at that point we'll have maximum or minimum. Okay. So you solve the system. When you solve the system, the second step, evaluate f at the solution at the points found in one. Maybe you have 3 points or 3 solutions or 4 solutions. Evaluate f at each one of them. Okay. What is the maximum value of f? The largest value. The largest value obtained. What is the minimum? هتكون smallest value. Smallest value. Okay. Okay. So to summarize, really to solve the system, to solve the extreme value problems, this one, okay, you need only to solve a system, really. You need to solve a system. This is the method of Lagrange multipliers. You need to solve a system. Once you solve the system, you find the solution, just evaluate. The largest is the maximum value of f, the smallest is the minimum. Okay. Before I give an example to illustrate the method, طبعا هنا notice the first observation is the following. In the previous section, many of the ideas were generalizations of those in Math 101, okay, in the previous sections. Here you have something different, something new. You have nothing similar to this in Math 101, okay, this is something new, okay. The second point, really, the proof of this theorem is not easy, so even so we cannot really explain it in a nice way, okay. We take this theorem gives us just a solution, describe the solution, and from it we get a procedure for the solution. Okay, so it is not an easy theorem to explain. Okay, but just you can always think of this as a vector equals lambda times vector. معناته the two vectors, the two gradients are parallel. They are multiples of each other. They are parallel. Okay. Now let me illustrate this with two examples. How to apply the method of Lagrange multipliers. Example: find the extreme values of xy equals xy on the circle x squared plus y squared equals then solution. Now, when you combine the two sections, section 14.7 and 14.8, and as I said, this section is just, you can think of it as a continuation of the previous section. Okay, so when you combine them together, it will not be difficult to decide which method you should use in solving this problem. Okay, find the extreme values of a function on a curve, on a circle. Okay. If it is not clear, you can always just go back and see what are the main problems. The first problem, local maximum, local minimum. So it is not okay. Second problem, we have regions, closed and bounded regions, basically triangular, rectangular, and circular. Well, our question now is not okay, and it is not clearly, it is not an optimization problem. So automatically, it is find the extreme values of f on a curve, So it is not difficult to decide that you are in this section, i.e. you have to solve using Lagrange. Use Lagrange multipliers. We call it LM. Okay. You need just to use Lagrange multiplier. The method of this section. What is the method of this section? You have these two steps. You solve the system. Okay, solve the system. Okay, So you just write and solve the system. That is the following. This is f sub x, f sub y equals lambda g sub x, g sub y, and then g equal to 0. Okay. So this is the system. Now f is known. F of xy equals xy. What about g? Gx and gy. What is g of x? What is g of x? What is your g here? Okay.
The
Exactly, but notice هنا written age subject to g equal to 0, or on the curve g equal to 0. So just collect all terms in one side and make it equal to 0. Okay. And when you collect all terms in one side, this is age هنا. This is age x squared plus y squared minus 10 equal to 0. So this is age g. Okay. هتكون age x squared plus y squared minus 10. Okay. Now compute. Compute. F sub x is y, and f sub y is x, and this is lambda, and this is lambda. G sub x, 2x. G sub y, it is h2y. And g equal to 0, x squared plus y squared minus 10 equal to 0. So you have 3 equations in 3 unknowns. Okay. The unknowns are x, y, lambda, x, y, lambda. What is the general procedure to solve a system? Okay. In fact, it is similar to math 002 orientation. In النهاية, you have to use all equations, okay, to find the solution. One of the general procedures is substitution. Okay, you substitute one equation in another equation. You work with them, so that usually, if possible, we end up with one equation in one unknown. When we end up with one equation in one unknown, it is easy to solve using orientation methods. Then after you solve, you do back substitution. Okay, back substitution. This is in general ايش يعني how to solve systems. Okay. فهير how to solve this. طبعا عندك if you compare 1 and 2, y equal lambda 2x and x equal lambda 2y, they are similar. So I will do the following: substitute 2 in 1. When you substitute the second equation, the first equation, you get the following: y equals 2 lambda times x. What is x from the second equation? It is 2 lambda y, 2 lambda y, 2 lambda y. This implies y equals 4 lambda squared y, 4 lambda squared y. Okay. And هنا y and y. Okay. This is varied. Is it allowed to divide by y here or not? Okay. Is it allowed or not? Okay. فهنا, if you remember in orientation, we always warn you of not dividing or cancelling unknown. For example, in orientation, if you have x equals x, if you divide by x, you get x equals 1. So is this the only solution for this equation or not?
No.
When you divide or when you cancel a common factor, you will lose a solution. So it is better always not divide by. Instead of dividing, just take it as a common factor. Take it to the other side and take common factor. x minus 1 equal to, and then x equal to 0 and x equals 1. Here you did not lose a solution. Okay, you get all solutions. But when you divide, you might lose a solution. فهنا don't divide. Now take it just as a common factor here. So this is hy minus 4 lambda squared y equal to 0. Then take y as a common factor with hy 1 minus 4 lambda squared equal to 0. This gives you hy equal to 0, or 1 minus 4 lambda squared equals 1. So this gives you hy equal to 0, or lambda equals plus or minus half. Because this gives you h4 lambda squared equals 1 over 4. Okay. So the second gives you lambda squared equals 1 over 4. So we get h lambda equals plus or minus half. Okay. So when I substitute the second equation in the first equation, I get these possibilities. Now I study each one of them. So if y equal to 0, what is the corresponding x? Where should I substitute? Where should I substitute? I substituted 2.
And
In 1.
third.
G.
I
G equals
I substituted 2 in 1. I work with 1, I get something. Then I have to go back h2 to 2. I have to go back to 2. Okay. This is if you just remember what you did in orientation, this is what you do. Substitute 2 in 1, you work with 1, then you go back to 2. Substitute back in 2. Okay. Now substitute back in 2, what do you get in it? What is x? X equals lambda times 2 times y. Y is 0. حتكون ايش 0. So this is ايش 0. So this is getting xy equals 0, 0. I get a point x 0, 0. But I get this point 0, 0 using how many equations? Only 1 and 2. When I use 1 and 2, I get 0 and 0. But I need to solve the system. And to solve the system, I have to make sure the solution satisfies all equations, not only bar 2 of the equations or 1 of the equations. So here, since I get 0, 0 from the first 2 equations, I have to check the third equation. Does it satisfy the third equation or not? Okay. Now, if you substitute 0, 0, you get h no. 0 minus 10 not equal to 0. So it is rejected. Since it does not satisfy 3. Equation 3. I needed to check equation 3 because I get this point only using the first 2 equations. So I have to check the third equation. Okay, so the case when y equal to 0, this case leads to no points. Okay, there is no point. Now you go to lambda equals half. Okay, lambda equals half. Okay, implies. Where do you substitute? Again, I substituted 2 in 1. I work with 1. Then I have to go back to h2 also. Okay. Substitute lambda into. When you substitute lambda into, what do you get now? X equals lambda equals half times 2y. You get hy. You get hy. So when you work with the first 2 equations, only 1 and you get x equals y. The relation between the x coordinate and y coordinate is that they are equal. What do I do with this relation now? Okay.
Substitute in the third equation.
In the third equation, exactly. You go now to the third equation. Okay, you go to the third equation. When you substitute in the third equation, you get an x squared plus x squared minus 10 equal to 0. لاحظ one equation in one unknown. I end up with one equation in one unknown. So this is x squared equals 5, and hence x equals plus or minus root 5. So what are the points now? X, y. If x is root 5 or minus root 5, what is y? Okay, what is y? The same, because of x equals y. This is the relation between them. Okay, x equals y. Okay, حيكون minus root 5. If x is root 5, again y will be root 5. So this is h, the first 2 points. Okay, now we take lambda equals minus half. Lambda equals minus half. Again, you substitute in 2, you get x equals minus y, minus y. Because x equals lambda, which is minus half, times 2y will be minus half, minus y, okay. And as in the previous day. So this now substitute in a 3, you get an x squared plus x squared minus 10 equal to 0, x squared equals 5, and hence x equals plus minus 5. Now, what are the points in xy points? Xy equal. If it is minus root 5, if x is minus root 5, what is y?
root 5.
Root 5. لكن if they are negatives of a, so y equals minus x, فحتكون root 5. Root 5. And if it is root 5, حتكون minus root 5. And these are the other 2. So I have the solution consists of 4 points. Now the second step, evaluate f at these points. Evaluate f at these points. Just recall what is f of xy above equals xy, the product. So when you multiply the coordinates, حيكون يقول هنا 5 وهنا 5 وهنا minus 5 minus. This is the max. This is the minimum. Okay. So the maximum value of f is 5, and it occurs at the points minus root 5 and root 5. The minimum value is minus 5, and it occurs at minus root 5 and root 5 minus root 5. So this is the solution. So basically, you have to solve a system. The main work or the main effort is just in solving a system, okay? And there are really many methods to solve systems. The general one, as I explained, but when you go through the solution, in fact, you see sometimes they are easy, sometimes they are average, sometimes they are complicated, okay? In the lecture note, I gave 10 examples. You will see different variety of levels. Some are easy, straightforward, some are not, okay? Average and difficult. The best way to just master the general procedure is to read the examples, ask about them, and then just practice. And then practice, okay? Okay. Do you have any question before I go to the next example? Okay, so let me write a second example, then you can ask me at the end if you have a question. Find the extreme values, of x, y, z equals x plus 2y plus 3z on the sphere x squared plus y squared plus z squared equals 25. So here, just a natural extension. The main problem stated above, okay, it was given in terms of two variables, okay. Find the extreme values of f of xy, and they gave xy equal to 0, okay. Now it can be generalized to three variables. Find the extreme values of f of xyz on the surface gxyz equal to 0. You can generalize it to functions of three variables, okay. What about the solution? Exactly the same. You just you generalize it, but in the solution now you will have and you have f sub x, f sub y. Then I will have f sub z also. F sub z equals lambda g sub z, okay. Natural generalization, okay. So this is you have it either in terms of functions of two variables or functions of three variables. So again, use Lagrange multiplier, okay. So I need to solve the system. What is the system here? It is the following, okay. F sub x, f sub y, f sub z. You need to add the z component, okay. Equals lambda dot times g sub x, g sub y, and g sub z, and then g equal to 0. Exactly the same as in the previous example, but we are adding an extra equation, okay, the z component, okay. What is your g here? What is g of x, y, z? If it's known, what is g? Again, as we did above, just take 25 to the other side. The whole expression equal to 0. You get g حتكون x squared plus y squared plus z squared minus 25. You have f and g. Go and compute and solve the system, okay. So this, when you compute, you get the following, okay. What is f sub x? It is 1. What is f sub y? It is 2. What is f sub z? It is 3. Lambda, okay. What is g sub x? It is 2x. What is g sub y? Again 2y. F sub z 2z. And g equal to 0. This is x squared plus y squared plus z squared minus 25 equal to 0. So you have now 4 equations in 4 unknowns. And the unknowns are x, y, z for the point and lambda and lambda. 4 equations in 4 unknowns. Okay. How to solve them? Again, I repeat what I said. again, go through the notes also. You will see different methods, different methods for solutions. Okay, يعني different procedure, but they all boils down to the all boil down to the same idea. You know, I need at the end, I need to use this equation to end up with one equation in one unknown. When I have one equation in one unknown, I can solve it using orientation and then just do back substitution. This is really the main idea. Okay, the main idea. So here, from the first three equations, they are nice equations. They are simple. Okay, but from 1 and 2 and 3, you solve for x, y, and z. What is x from the first equation? 1 over 2 lambda, 1 over 2 lambda. What is y from the second equation? 1 over lambda. What is z from the third equation? It is 3 over 2 lambda. So I have these, I have these x, y, and z in terms of lambda, okay. So let me give this number 5, okay. What should I do with these x, y, z? What the values of x, y, and z?
Substitute in the fourth.
Substitute in the fourth equation. You will see why, okay. We substitute in the fourth equation. What is x squared? 1 over 4 lambda squared. What is y squared? 1 over lambda squared. What is z squared? It is 9 minus 4 lambda squared. Minus 25 equal to 0. Notice when I substitute, I get an equation in one unknown only, in one unknown, okay. So I can solve easily using orientation, okay. It is always, I put in my mind, you know, to use these equations to end up or to one equation in one unknown. I can solve it easily and then just do back substitution. Here the unknown is in the denominator, so I can kill the denominator by multiplying by 4 lambda squared to kill the denominator. When you multiply each term by 4 lambda squared, what do you get? You get 1 plus 4 plus 9 minus 100 lambda squared equal to 0. So this implies that I get 14 equals 100 lambda squared. So this is h lambda squared equals 14 over 100, and hence lambda equals plus or minus root 14 over 10. So I get lambdas. Now if lambda equals root 14 over 10, how to get x, y, z? Okay, how to get x, y, z? How? Either use 5.
Substitute in the equation.
Yeah, 5 عندك 5 اللي هي طبعا these 3 equations, what I call 5, they come from 1, 2, and 3. So either you substitute here or substitute in 1 and 2 and 3. They are the same, okay. 1, 2, and 3, the same as 5, the 3 equations. So let me say substitute in 5 because just when you substitute lambda, I get x, y, z directly. So substitute in 5. When you substitute in 5, you get the following. You get h 5 over root 14, 5 over root 14, and 10 over root 14, and 15 over root 14. When you take lambda equals the negative minus root 14 over 10, again, when you substitute in 5, you get the same thing, but with the negative, You get the same thing, but with negative, okay. So the system has two solutions, two solutions, okay, this system, okay. Now, just evaluate f. When you evaluate f at these points, and you simplify, you get h5 root 14, and this is minus 5 root 14. So this is the max, and this is h, the minimum, okay. So this is the maximum value, 5 root 14. This is the minimum value, minus 5 root 14. Okay. فnotice in this example just an observe. You have 4 equations in 4 unknown. We expect it to be more difficult than the previous example. The previous example have 3 equations and 3 unknown, but it seems no. The solution here is easier and quicker than the previous example. Okay. So sometimes you have this dilemma. Okay. Okay. So this is h, this is These are two examples. In the note, you have more examples. So again, just read the examples, try to understand them. Okay. If you have a question, you can ask. As I told you in the beginning, in fact, some of the examples are easy, some of them are really difficult. Okay. So you have to practice until you feel comfortable in solving these systems. Okay. This is the first point in this section. The second point, have a second problem, طبعا. I will try to make a recording for it. Okay, I will record it. I will make a recording during the weekend, and then I will ask you just to watch the recording. It is really a generalized problem. Okay, so I will do a recording and I will leave it for you to watch. Okay. Now, if you have a question, okay, now, okay, تفضل علي منصور.
دكتور متى أحتاج إني أشيك على النقط أن صحيحة النقاط في المعادلة متى
هي هناك أنت make sure إنه when you get a point, when you get a solution, make sure إنه you use all the equations in the system. If you get this point using the 3 equations or 4 equations, all the equations in the system, then that you don't need to check. Okay. But if you find a solution using only 2 equations, you have then to check whether it satisfies the 3rd equation or not. Okay. 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 قاسم، ايش سؤالك قاسم؟
دكتور بالنسبة للحل دائما يكونون حلين واحد ماكسيمم ولا يمكن يطلع 4
Again, can you repeat your question? It was not clear. Okay. Your voice was not clear. Okay. Can you repeat your question?
بالنسبة للحلول
أيوة. Okay.
ممكن يطلعون أكثر من حلين واحد